Welcome back, dear friends. In this video, we will be talking about a very important topic in algebra, which is called rational equations. So, as I mentioned in my previous video, when we are trying to solve an equation, we are looking for a numerical value for the unknown variable. But the only difference here is that instead of having a combination of numbers and x's or variables, here you have everything in the form of fractions. So it could be a few fractions added, multiplied, or subtracted together, but you have to solve the equation and find a value for x. So let's see, a typical one would be something like this. Here you have two fractions, but the fractions are in terms of unknown variables. But before jumping into solving the equation, there are a few things you have to always follow and learn before trying to, starting to solve the equation. So these important notes, in this, I just call them, I will explain them in side note. So the side note one, when it comes to rational equation, it's adding or subtracting, fractions which have different denominator. So let me remind you, here, if we have two fractions, different denominator, we cannot just add them together in one go. First of all, we have to make sure they have the same denominator. We have to do common denominator. The most simple one is the multiplication of the two. So 10 here. Remember, if we want, in math, whatever you do to an equation, you should do it to both sides. Or whatever you do to a fraction, okay, you have to do both to the numerator and denominator, so the value of the fraction doesn't change. So here, what I'll do, if I want to make the denominator 10, I have to multiply this one by 2 and then this one by 2. So it would be 6 over 10. And then for the second one, this will be multiplied by 5. This will be the same. So that would be 5 over 10. So here, both of them have got the same denominator and I can add them together. Let's continue common denominator topic with instead of numbers, with letters. So here, the first fraction, it's 2, denominator is 2, the second one is 3, so I'll do 6 as the common denominator. Here, this one is multiplied by 3, so that would be 3 over 6. The second one here is multiplied by 2, so this one should be multiplied by 2, so it turns into 2x over 6. Now I can simply add them together, 6, and then here 3 would be added to 2x. So no matter if it's like letters or variables, like letters or variables are the same or constant, you have to do common denominator. Side note 2, this is a very handy trick or tool that you will need in order to solve rational equations. But there is a very important condition which should be met before using this tool. So let's say you have two fractions, one fraction on this side and one fraction on the other side. And the numerator and denominator could be anything. It could be numbers, positive, negative, radical, exponents, whatever. But the only condition is that there should be one fraction on each side of the equal sign. Okay, then we could say the tool that we are talking about is cross multiplication. Then we could say A multiplied by D is equal to B multiplied by C. Okay, so we change the fraction format into the linear format, right, by using cross multiplication tool. But please do not forget, before you can use the cross multiplication tool, you have to make sure that there is only one fraction on either side of the equal sign. Side note number 3, which is also very important, is that denominator can never be 0. Because if the denominator is 0, let's say 2 divided by 0, in math, it is called such fraction is called undefined, okay? And it's not possible, okay? So whenever we have a fraction that the denominator is expressed in terms of variables, we have to see what values make the denominator 0 and then exclude them from the answer. And these values which make the denominator 0 are called non-permissible values, or for short, we just simply call them NPV. So before jumping into, solving a rational equation, you have to first find the NPV value, the values which make the denominator of each fraction 0. So this step should be done before any simplification, okay? So before doing any simplification, first identify which values make your denominator 0 and then call them NPV. And if any of your roots is equal to the NPV, that value cannot be accepted. So let's start with a simple rational equation. Here I have 3 fractions. Each of them have got a different denominator, but let's remember the first step is identifying NPV. So I have to look for the values which make the denominator of each fraction 0. So here 5x should never be 0. Okay, so what value makes the 5x 0? So 5x, condition 1, 5x should not be 0. So if x is 0, I would be in trouble. So I have to make sure, I have to make sure the x is excluded from the answer set. So I call NPV 0. This one, it's always 20, so I'm not in trouble. But this one shouldn't be 0 either. So 2x cannot be 0. But the value which make it 0, which make 2x 0 is also 0. So my NPV values here is only 0. Now let's start by solving this one. So as you can see here, I have 2 fractions on this side, but 1 fraction on the other side. And if I want to use the cross multiplication tool, I have to make sure either side of the equal sign there is only 1 fraction. So on this side we are safe, but on this side I have to do common denominator. The most simple common denominator is 40x. So here this one is multiplied by 2x, 14x. This one is multiplied by 20. The same thing should be done to the denominator. Here we can just do, in the next step, we can just add them together, 40x, 14x plus 20. And then on this side, I have 3 over 5x. The next step would be cross multiplication. So 3 multiplied by 40x would be equal to 5x multiplied by, remember, multiplied by 14x plus 20. That's why I put it inside the bracket to make sure that 5x is multiplied by both terms. So let's write it down. 3 multiplied by 40x equals to 5x multiplied by 14x plus 20. I always advise you, when it's a binomial or trinomial or a bigger expression, always put it inside a bracket. Next step would be dividing, because if you can see, I can divide both sides by 5x. It's a common factor to make it simpler. So here, if I divide both sides by 5x, this side would be cancelled out with 5x, but here this will turn 40x divided by 5x would be 8. Okay, so what is left here? It's 8. Turns into 3 multiplied by 8, and on this side I will be left with 14x plus 20. As you can see, now it's very simple. instead of having like a quadratic and solving a quadratic equation, I just reduced everything to a linear one. But remember here, I divided everything by 5x. So 5x, usually the root is 0, but because it's the same value as NPV, we wouldn't accept it as one of the roots. Now let's continue. 24 equals 14x plus 20. In order to isolate, I add negative 20 to both sides. So 4 equals 14x. The final answer is 14, 4 divided by 14. Or you know that you can just simplify both sides by 2 over 7. So here, I want to suggest you always, when you're doing an equation, go back and check your answer. So let's do it here. So the equation I had was 3 over 5x equals 7 over 20 plus 1 over 2x. And the reason why I want to, ask you to check the answer here, because first of all, you were dealing with so much calculation, and second of all, you were dealing with fraction. And it's very good. It's very good to make sure that you've got the right answer. So here, 3 divided by 5x. Instead of x, I simplify, substituted. This is the x. 7 over 20. Instead of x, I put 2 over 7. Okay, so here, let's simplify. This one would be 3, 10, 7, 7, 20. And here would be 1 divided by 4, 7. Okay, to continue, here I have 2 fractions actually multiplied, right? Because 3, if you remember, it's always like, considered as any constant can be considered as a fraction with the denominator 1. So here I follow the division rule for fractions. I write the first fraction, multiply it by the reciprocal of the second fraction. So 3 multiplied by 7 over 10. On this side, first let's simplify this fraction. So it will be 1 multiplied by 7 over 4. And then this one, I didn't change anything. Okay, so next step, I just simplify this side, 21 over 10. Here, that would be 7 divided by 20. And here I have 1 times 7 divided by 4. So on this side, I have to do common denominator. Okay, let's do it. So the most simple common denominator I could have is 20, or some of you might go with 80. It's perfectly okay, but I prefer 20. So 20, the first fraction doesn't change, but the second fraction, as you can see, it's multiplied by 5. So that would be 35 by 20. Now I can just simply add the 2, 42 over 20. 42 over 20 can be simplified both by 2, 21 over 10 on this side. And as you can see, even this side, it's the same thing, which means you are on the right track. Now let's do another rational equation. This is a little bit more difficult than the previous one. Here you have 2 fractions and a constant. First thing first, we have to make sure, we have to find what are the NPVs. NPVs, just as a reminder, are the values which make the denominator of each fraction 0. So the first value would be 0. The second value would be -2, because -2 would make this fraction's denominator 0. So I would say the NPV value are 0 and -2. These are the forbidden values for this equation. Okay, so let's start by solving. What I'll do here, I'll do common denominator. Common denominator would be the multiplication of these two. So if you can see here, I have to multiply this one by x plus 2. The same thing, I do it here. So it turns into this. And the second fraction, I have to multiply it by x. So I have to do the same here, right? After this, I have to just simply do simplification. So let's say 4x plus 8 from the first fraction, 8x here. And on the denominator, I have x multiplied by x plus 2. On this side, I have 4, which I give it the denominator 1, because after this step, I want to do cross multiplication. So here I would say 4x plus 8x is 12x plus 8, right? And then I'll do cross multiplication. So 1 times 12x plus 8 equals to 4. And then x multiplied by this one would be x squared plus 2x. So I just put it here. Okay. Next step would be here I have the biggest power is 2. So this is a quadratic equation. I have to solve a quadratic equation. In order to solve a quadratic equation, you have to move everything to one side, okay? So what I'll do here, I'll just do some simplification and moving around. So 4x squared, 8x, and then on this side I have 12x plus 8. So I move everything to one side, 4x plus 8, 4x squared plus 8x. This one will be moved to this side, so that would be negative. The sign will flip. Negative 12x, 8. The sign will flip when it's moving to the other side. Or some of you feel comfortable if you add negative 8 to both sides or negative 12x to both sides. Well, the answer is the same. So after simplification, okay, you will have 4x squared minus 4x minus 4. But if you look closely, like all of them have got the same coefficient. So what I'll do, I just factorize a 4. So it turns into 4x squared minus x minus 1 equal to 0. So here I have to, I have to solve this quadratic equation. But the good thing is all the coefficients are really small numbers. So let's see. In order, as I just mentioned in my other videos or even during my classes, the most secure method to solve a quadratic equation, it's quadratic formula. Okay? Unless they ask you to, follow or solve from a specific method. Other than that, the formula is the most, easiest, and it's always give you, it never disappoints you, it always give you the answer. So let's say here, before using the formula, you have to identify A, B, C. A being the coefficient of x squared, B the coefficient of x, and C is the constant. So here A is 1, B is negative 1, C is negative 1. A, B, C. Now substitute it in the formula. X is negative B plus and minus B squared minus 4 times AC, and the denominator is 2 times A. After simplification, that would be 1 plus and minus radical 5 divided by 2. So you have 2 roots. And after this step, you have to make sure the roots do not overlap or are not the same value as your MPV. Otherwise, they wouldn't be accepted. But here, your MPV values, if you can remember, the MPV values were 0 and negative 2. But your roots are something different. So both of the roots are accepted. One more example. At this point, I really suggest you pause the video, try to solve the equation on your own, and then resume the video and check your answers. So here we have to start by defining the NPV. NPVs, just as a reminder, are the values which make the denominator of each fraction before simplification to 0. So here I have 3 fractions. I have actually 2 different denominators. So I have to extract the values which make each of these denominators 0. So x plus 5 cannot be 0, x minus 5 cannot be 0. So the forbidden values, or the NPVs, are 5 and negative 5. Okay, so let's dive in to solve the equation. So I do common denominator. Common denominator on this side would be x plus 5 multiplied by x minus 5. So I'll do it on both sides, So here, this side, as I just mentioned, I always prefer to put them in a parentheses when they are, binomial or bigger expression. So here, this side is multiplied by x negative 5. The same thing should be done here. And this thing is multiplied by x plus 5. So I add x plus 5 here, right? This is what I did. X minus 5, negative. So I transferred the negative to 5. So negative 5, x plus 5. Okay, on this side, I didn't do anything. So at this point, I'm trying to have one fraction on each side so I can use the cross multiplication tool. I'll do simplification. So this side, I would have x squared minus 5x minus 5x plus negative 25. So here x squared, but here that would be negative 10x negative 25 equals 14. And then now I have, at this point, I have one fraction on this side, one fraction on this side, and eligible for cross multiplication method. Just to remind you, cross multiplication, right? Tool. Remember, this is the most important tool you need to solve rational equation. And then, so just to a quick reminder, one fraction on either side, a times d, should be equal to b times c. So I'll do this multiplied by this equal this multiplied by this. This is what I did, but you can see here x plus 5 is repeated here and here. So I will divide both sides by x plus 5. Okay, so it is reduced, or it's simplified to 14. X minus 5 equals x squared minus 10x minus 25. As you can see, the biggest power is 2, so it's a quadratic. I have to move everything to one side. So here, that would be 14x minus 70 equals to this. I move everything to one side and simplify. That's what I did. Now I have one quadratic equation. I prefer to use the quadratic formula. A is 1, B is negative 24, C is 45. Next step would be substituting in the formula negative b plus and minus b squared, negative 4ac, 2 times a. Here, I want to do another side note. So under the radical is 396. Okay, so 396, I would know 396 is 4 times 99, or in other words, 4 times 9 times 11. So here, the 4 can come out as 2, the 9 come out as 3, but 11 stays under the radical. So here I can go ahead, instead of 396, I will put it as 24 plus and minus 6 radical 11 divided by 2. What I can do here, I can factorize the 2. So that would be 12 plus 3 radical 11, right? Divided by 2. And these two will simplify, okay? So this is why the final answers would be 12 plus and minus 3 radical 11, okay? So the first root would be 12 plus 3 radical 11. The second one would be 12 minus radical 311. Let's do one more interesting example. Here I have another rational equation. First thing, I have to identify NPV. So here, let's say I have x minus 2, which x minus 2, x minus 4, which cannot be 0. Also, I have here x squared minus 6x plus 8, which shouldn't be 0. But if you look closely, or if you use the quadratic formula to find the values which makes this equation 0, which happens to be the roots, the values are exactly 2 and 4. Okay, so the NPV value are 2 and 4. Okay, so let's do cross multiplication, common denominator, and then cross multiplication, and then solve for it. So here I do common denominator. Here this one should be multiplied, I always put it in a bracket, x minus 2, x minus 2. Okay, and on this side multiplied by x minus 4, x minus 4. So x minus 2 here plus x minus 4, and on this side so here what I did, I just tried to simplify. So here that would be x minus 2, x squared minus 4x. I simplify, it will be x squared minus 3x minus 2. So what I did, I simplified the first side of the equation, and the second side I just didn't do anything. So here it's eligible for cross multiplication, this multiplied by this. Okay, so let's do it together. As you can see here, this multiplied by this equals this by this. But if you look closely, this is repeated, right? This is repeated on both sides. So I can easily divide both sides by this. When you divide, both sides, even in the previous example, when you divide both sides or cancel out a factor, they become the potential roots. Okay, but if you simplify, okay, if you try to find the roots, you would see that the roots are exactly 2 and 4, which are the same value as the NPV. So that's why, even though 2 and 4 can be potential roots for this rational equation, but because they're the same value as the NPV, we do not accept them. So here, after simplification or canceling out, I have this thing. Now I have to move everything to one side, right? That's it. And then from here, I can either use the quadratic formula, or if you feel comfortable, you can use any other method. For this specific example, I tried to use factorization just as a practice. So I'm looking, the first thing, this is 1, okay? This is the condition. So I'm looking for two numbers. If I add them, I get -3, and if I multiply them, I get -4. And the two numbers are -4 and 1. See, it satisfied both. So I can factorize it in two brackets. Now 2 brackets multiplied equal to 0. Remember, A multiplied by B by C by Z equal to 0. Then we said that any of these is a potential 0. So that means either x minus 4 is 0 or x plus 1 is a 0. From here, we found two answers, 4 and 1. But if you go back and check the NPV value, you would see that 4 was an NPV value. So that's why we don't accept it as a final root for the rational equation. And the only acceptable answer, or the only acceptable root, would be x equal to 1. Now let's continue this video with the last example, which is another rational equation. Here you have to first identify the NPV values. So the NPVs are either 0 or 1. Please, again, as I mentioned, pause the video, solve it on your own, and check back, resume the video and check back your answer. So here Next step would be doing common denominator. That's what I did, both sides. Okay, what I did here, I just simplified. At this point, I have one fraction on this side of the equation, one fraction on this side, so I can do cross multiplication. So this multiplied by this equals this by this. As you can see here, x minus 1 is repeated on both sides, so I divide both sides by x minus 1. So x minus 1 is a potential root for this rational equation. So x equal 1 could be a potential root, but we have to make sure it's not the NPV value. We go back here and it happens that it's exactly the same value as the NPV, so we do not accept it. So let's continue and see if we can find any other roots. So after simplification, we would have 2x squared minus 2x minus 1 equals to 3x. If we want to solve this one, we have to follow the quadratic equation method. And for this specific one, I prefer to use the formula. A is 2, B is -5, C is -1. I simply substitute negative b plus or minus b squared minus 4ac 2 times a. So under the radical is a positive number, 33. So the two answers would be 5 plus radical 33 divided by 2. The other one would be 5 minus radical 33 divided by 2. I hope you enjoyed this video. Please don't forget to subscribe. See you next time.